Okay, let's give you guys some practice now. So following on from some of the earlier videos, we now have the ability to work out dy by dx of a parametric curve. You simply differentiate the y, you simply differentiate the x, and then you have yourself dy by dx. Okay, so now we've established that. So now let's put it to use. So given these parametric equations, come up with the equation of the tangent line at t equals pi over 4. So press pause and have a go. Okay, so to do this, we want to know where the particle will be at time equals pi over 4. So to find out where the particle will be, find the x coordinate. So and then later on find the y coordinate. So the x coordinate at time pi over 4 will be secant pi over 4. That will then give us the x coordinate. But what is secant pi over 4? So we've seen this triangle many times. This is the famous triangle here. Secant. So remember, cos will be this, secant will be this. So secant pi over 4. So secant, the angle here, it will be root 2. It will be root 2 over the adjacent, which is 1. So it will be root 2. So the x coordinate will be root 2. And then to find out the y coordinate at time equals pi over 4, to find out the y coordinate, we would put it into here. So tan of pi over 4, tan of pi. So this is pi over 4 is this. Tan will be 1. So at time equals pi over 4, the x coordinate will be root 2. The y coordinate will be 1. So that will so at time equals pi over 4, the particle will be right at this point here. So to find out the equation of the tangent line, we will need to know the gradient at that particular point. We have the x coordinate, we have the y coordinate. We now need to know the gradient at that particular point. So to find the gradient, you simply differentiate this. So you differentiate this, and then you simply differentiate this. You simply differentiate this. So that's this bit here. Okay, so to find out dy by dx of that tangent line, we would need to know the gradient at this particular point, or the gradients given by this. So it's saying simply differentiate this, and then simply differentiate this, and then you have yourself dy by dx. So differentiating this, so that's this bit here. When you differentiate tan of t, it will give you secant squared of t. Now we need to differentiate. We now need to differentiate this. So to differentiate secant of t, or secant of t, secant of t will be this. Secant of t will be this. So secant will be this. So imagine it as this. Imagine secant as this, and then rewrite it as this. So when you differentiate this, it will be -1, and then the bubble stays intact. The power gets minus by 1, and then you times the derivative of the bubble itself. So we are now differentiating this. We are now differentiating secant of t. So that will then give you this. Tidy this up. Tidy this thing up. It will then give you this. So when you differentiate secant of t, it will give you secant of t times tan of t. So when you differentiate secant of t, it will give you this. So hang on, let's start again. We are trying to find out dy by dx. We are trying to work out dy by dx. To work out dy by dx, you simply differentiate this, and then you simply differentiate this. Well, when you differentiate this, it will give you secant squared of t. That's this bit here. And then when you differentiate secant of t, it will give you secant of t times tan of t. So when you differentiate this bit, it will then give you this. Okay, so dy by dx is this thing here, but it's quite messy, so tidy it up. So that would then simply become this, and then it's still messy, so we can tidy this up. Secant of t, we can imagine it as 1 over cos of t, and then you've got yourself a divide here, that's this divide here, and then tan of t is this. So now tidy this up, times the reciprocal, blah blah blah, it will then give you this. So dy by dx is simply 1 over sine t. Well, 1 over sine t is, well, sine t is this thing here. Sine t is 1 over root 2. So now that, so sine t is this thing here. But then you've got 1 divided by this, so it becomes root 2. So dy by dx is root 2. So now we know that when time equals pi over 4, the particle will be right here, and the x coordinate will be root 2. The y coordinate will be 1. We now know the gradient at that point, which is root 2, because dy by dx is root 2. So now we know the gradient. So the equation. So we should be able to work out the equation of this straight line, of this tangent line. So the equation of a straight line is y equals mx plus c. We now know the gradient, so put that into here. So we've done this before, so it's blah blah blah. The equation of that tangent line will be given by this. So if you get a graph plotter and plot it, it will give you this blue line here. Okay? So the equation of the tangent line is given by this.